Today we're going to be starting our unit on proportional reasoning, and we're going to start with ratios, rates, and unit rates. Some of this, if not all of it, should be a review, so let's get started. Some definitions first. A ratio uses division to compare two numbers, and the comparison of A to B can be written in three ways. You need to know these three ways to write a ratio. A to B can be written as a fraction with A as the numerator, B as the denominator. A to B can be written with A and B with a colon in between it. And then A to B can also be written just like that, A to B. Sometimes the word two can be different, but generally you're going to see that two. The thing about writing a ratio is you need to write them in simplest form. And I did forget to say a ratio is really just, I'm going to go back up here. A ratio is just a fancy word for fraction. So these are really fractions. And so when you think about a comparison to between two numbers, that's what a fraction is. So, like 1 to 2, 1/2. And maybe you've heard these on a TV commercial or something where they say, 1 out of every 4 dentists or something like that. What they're doing is comparing that one dentist to the 4 dentists. So it can be written as a fraction, which is generally how you'll see them. Because it is a fraction, you need to write them in simplest form. And so I'm just going to write this in big letters right here. Actually, I'm going to highlight this. Simplest form. And this is an absolute test question. You need to be able to write a ratio in these 3 different forms. So because it is a fraction, you always write your fractions in simplest form. So let's just write 5 to 35 as a fraction. 5 is your numerator, 35 is your denominator. Well, that obviously can be reduced by dividing both of these by 5. So it's going to be 1/7. Then you're going to write it with a semicolon, and then you're going to write it with the word 2 in between. So test question. Let's do this. We have 6/15. You can divide both of these by 3. So we're going to have 2/5, or you can have 2/5, or you can have 2 to 5. Here it's already as a fraction. Sometimes the numerator will be larger. Remember, that's just an improper fraction. I can divide both of these by 5. So I'm going to have 3/1. So 3/1 or 3/1. Absolute test question. Okay, so let's look a little further. Here we've got a ski resort, and they have 15 easy, 25 intermediate, 7 difficult, and 11 expert-only trails. And we're going to rate the ratio intermediate trails to easy trails in 3 different ways. It's important the way it's written, because the way the comparison is going is from intermediate trails to easy trails. So because the intermediate came first, that's where I'm going to put that 25 on the top, and here you can see that here. And then the easy trails were 15, so there's my 15 down there. So again, wrote it in simplest form, 5/3. And then I'm going to write it in 2 other ways. So I'm going to write that with the semicolon in between. So I'm going to say 5/3, and 5/3. So these could all be possible test questions. So now let's look at the comparison between difficult trails and expert only. Since difficult was listed first, the comparison is going from difficult to expert. Since that's already simplified, I don't need to do anything with that, but I can certainly write it in 2 other forms. Now they're comparing easy trails to difficult trails. So again, the proportional reasoning is read from left to right. So I'm comparing easy to difficult. We're up at the one above. It was difficult to expert. So my easy trails are 15. And my difficult trails are 7. Nothing to reduce, but I can write it in 2 different forms. So you can see that here's the 7 and here's the 11. That's the way the comparison is going from left to right. A rate, now we were just looking at ratios, but a rate is actually a ratio of two quantities that have different units of measure. So a fancy way to kind of say that is you're comparing two fractions where the numerator and the denominator represent different units of measure. So in other words, dollars to gallons, miles to hours, girls to boys. And rates and ratios are equivalent if they have the same value. So if I'm looking at these two comparisons, so this first one, it is $4 to 70 gallons. Well, that's a comparison of dollars to gallons. And here I have another comparison of $3 to 52 and a half gallons. So they're already written in one of the forms, but I'm going to write them in the same form as a fraction because I want to see if they're equal to each other. It's like you want to know which one's the better deal. You're looking at these gas stations, they're across the street from each other, and you have no idea which one's going to be the better deal. So, you can see which one is greater or less by writing them as a ratio or a fraction. So this first one, I have $4, and that will get me 70 gallons. But then I have, I'm sorry about that, that came on and it was not supposed to, 70 gallons. And then over on this one, I have $3 for 52 and a half gallons. So there's that comparison from dollars to gallons. But I don't know which one's the better deal. And I want to make sure that I'm going to get, I'm going to pay the less. So remember with fractions, you can use cross products to tell if a fraction is equal or not. So ignoring the dollars and gallons, we're just going to look at the numbers. And I'm going to take 70 times 3. Well, that's 210. And then because we're using calculators now, I'm going to take that 4 times 52 and a half, and I also get 210. So these two gas stations are offering gas at an equal price. So remember, if these two numbers were different, you could tell which one was more and which one was less. A unit rate is a rate that has a denominator of 1 unit. So let's say you go to the grocery store and you're like, well, look, here we've got gallons again, $3.50 for 7 gallons. Well, that's nice, but I really want to know how much it is for each gallon. I don't care about, 7 gallons. I want to know each gallon. So what I did was I took this bottom number down to a 1. And so to do that, I had to divide it by 7. Well, remember with a fraction, if you do something to the bottom, you have to also do it to the top to maintain that comparison or that ratio of top to bottom. So I also have to divide this by 7. Well, $3.50 divided by 7 is actually 50 cents. So that's kind of easier to look at. Instead of 7 gallons, we're just taking it down to 1 gallon. And that's a unit rate because it's for one single unit. So let's just look at a couple of here. So we have 16 degrees in 2.5 hours. So again, that 2.5 went down to 1. So I had to divide it by 2.5 to get that. So now I'm going to divide 16 by 2.5. And I get negative 6.4 degrees an hour. So here we had 6 games. I want to know each game. So I divided by 6. So what I do to the bottom, I have to do to the top. So I'm going to divide that 74 by 6. And I get 12.3 repeating. So here's 24 gallons for $3.75. And you notice it's always the bottom number I'm taking down to 1. I always want to know that single unit for the bottom denomination, not the top. So I'm just going to divide this by 375, and I'm going to get 6.4 gallons. So hopefully some of that will be a review. If you have any questions, we're going to be going over it in class again tomorrow. So watch the video a couple of times. The big takeaways are going to be the ratio is a fraction, and you need to be able to write it in 3 different ways. Simplest form the comparison always goes from, just like you're reading a sentence, from left to right. So the comparison is between intermediate trails to easy trails on that example. And then you can always tell if a rate or a ratio are equal to each other just by using those cross products, because they really can be just written as a fraction. And then a unit rate, it's always the bottom unit that we're going to take down to that single unit.